Good morning, everyone, and welcome to our webinar, ArcGIS Photogrammetry for 3D Applications. My name is Kurt Schwope, and I'm joined by my colleagues, Kyle Talbot, a solutions engineer on the Esri Remote Sensing and Imagery team, and Calvin Kwong, a solutions engineer on our national government team. Today, we're going to go on a journey. We're going to go visit the Nkota Wild Reserve in Malawi, Africa. This is the oldest nature reserve in the country of Malawi. It covers an area of 1,800 square miles and it's located in the Rift Valley. Its past history has been a little bit troubled. It experienced a fairly large poaching crisis and a little bit of a devastation going on in the habitat. But recently, the African Parks Organization took over management of the park, and they've turned it around and have made a fantastic change to this area. The largest thing they did was reintroducing over 500 elephants from other parks that were located in Malawi to repopulate the elephant species within this park. They've set up security perimeters. They've built facilities. They've done a number of things. They've added a number of guards and wardens to help protect the animals. It's been a fantastic turnaround. And so we're excited to be able to show you the work that we do when it comes to remote sensing and photogrammetry and use the Nkota as our sample data set as we go through the webinar presentation. In today's safari, we're going to cover a few key topics. The first being, we're going to introduce the ArcGIS imagery platform and how it's used with photogrammetry. We're going to demo how we can create different terrain models using Ortho Mapper inside of Pro. We're going to talk about the use of drones and how they can be used to create high-resolution 3D site models, and we're going to show you live demos of that. And then finally, we're going to wrap up with taking all those different foundation products that we generate through photogrammetry to create the various information products that could be used to help manage the park. Before we proceed with the presentation and the demo, though, a few housekeeping issues. First of all, we're going to be recording today's presentation, and you'll be getting a link to it, and so you'll be able to revisit and share it with your friends. Number two, we're going to try to answer all your questions that you might have as we go through the presentation. Just click that questions tab down there at the bottom of your dialog box, type in your questions, and we'll respond either as you type them in, and at the end, we'll try to cover those depending on the time we have. We're also going to be asking some polling questions. We just want to get your feedback and see where you stand as users of the technology. And then finally, please contact us. We have email for Raquel, and she can get a hold of us on any questions that you might have that you think about. So before we go into the presentation, let's go ahead with our first polling question. Okay, Raquel, do we have the results of the polls we can show? Okay, but it looks like most of you understand the principles of photogrammetry, and so that's great. So this will be a little bit of background information for you as we go through our presentation, but hopefully you'll still be able to learn how ArcGIS can work with photogrammetry. So moving on through the presentation, probably the best way to start is with the science of where. And this is how Esri sees the world. The GIS is the way to connect all types of information, whether it be from built environments or natural environments. That's the role of GIS, is to interconnect all these different sources of information. And imagery and remote sensing is just a fundamental part of this. It's a primary source of geospatial information that users can use to create all types of information with regards to the terrain in their environments. And we've put together a solution inside of the ArcGIS platform that allows us to do this very effectively. It starts with the ability to bring in content from a number of different sources, whether it be aircraft, satellites, planes, and then be able to manage that inside of a system that allows access to all that different data, both for visualization and for processing. Probably the first step in the processing environment is to make sure that that data is actually authoritative, that it's geospatially accurate. And to be able to do that, we use photogrammetry. And that allows us to ortho-rectify the imagery and create a number of different information products, such as digital elevation models, digital surface models, those type, and ortho photos to be used as base maps. From there, once that imagery is geospatially accurate, we can do different types of analysis of the data. And the first one is to gain insights. Insights on demand is the direction we're going now. And this incorporates now the use of GeoAI and the automatic detection of different things inside the imagery. This used to be a very manual process before, using different visualization techniques, but more and more we're starting to introduce GeoAI, artificial intelligence means to actually start collecting and extracting features out of the imagery on the fly. And then finally, we want to do some detailed raster analytics, some analysis. This is finding the spatial patterns within the imagery. And this has been a mainstay of remote sensing for a while. But with the introduction of GeoAI, we're able to take raster analytics and the extraction of features to a whole new level. During today's webinar, we're going to be digging more deeper into the photogrammetry and the finding the spatial patterns as we go through the presentation. This is how those tools stack up inside the platform. Once again, this is kind of a flow chart of a workflow, if you will. The raw sources coming in, those raw sources have to be managed. We use a data model called the Mosaic Data Sets to manage all our imagery. This provides very powerful tools that allow us to very quickly find the pixels that we want to work with. It allows users not to think in terms of files, but to think in terms of areas of interest. So they don't have to worry about where this image file is or this image file is. They use the Mosaic data set and they just tell ArcGIS, I'm interested in this area, find the pixels that I need. In turn, we can use those Mosaic data sets. We can ortho correct those using our photogrammetry tools, whether that be from drones, satellites, or aerial tools, and we'll show that. And then the imagery can be exploited in different ways. Probably one of the most common ways now is with the Image Analyst extension for Pro, which we're going to show in detail as we go through the presentation. So these are the three primary products that we're going to be talking about today. The Image Analyst extension for ArcGIS Pro, the Ortho Mapper, and SiteScan for ArcGIS. So just so you know, the Image Analyst extension is available for Pro now, and it includes these key functions, all revolving around imagery. If you have a need to use imagery, do remote sensing within your organization, we really encourage you to look at the value that the Image Analyst extension will bring to your solution. But let's go ahead and jump right into the creating of this authoritative content. And that's really photogrammetry all it is about. It's being able to take these raw sources from different platforms and be able to make them extremely geospatially accurate and precise. And it does that using a method of photogrammetry. So you can imagine if you were flying over a particular area, you would collect all these different photos. And the question is, well, why can't I just use those raw photos as a base map? Well, this diagram will kind of explain that. So let's go ahead and throw a grid over this aerial photo. And the C stands for the center point of that image. Now, if you look closely, you're going to see some issues here. The building right near that center point, it's straight down. It's located right where it should be. But if you look at that building off to the side, you'll notice that the top corner of the building is at a different location than the bottom corner of that image or of that building. So if you were to use this photo as a map, the top of the building would be at a different XY location than the bottom of the building. And when I tell you that hills and mountains do the exact same thing, you immediately realize the problem that brings. That's called layover or relief displacement. So to really use imagery as a base map, you have to correct for that. The other thing that happens is that plane is flying along and it's not pointing straight down. So it knows where that center point is in relationship to the location of the plane. But as that plane tips and tilts as it flies through the air, that center point gets dislocated off the ground. And so you have to work with different rotation angles to correct that. So the actual center point of your photo is at the same GPS location that you've determined in your aircraft. So these are the different problems that you face. So the way we can fix that is using overlapping stereo and triangulation. So in this particular case, if you look at these two images, I found the center point for both of those images. And what I can do is start building a mathematical relationship with tie points. So tie point 1, 2, and 3. And you'll see that I can just read the coordinates of all those tie points, and I can start defining a math model that explains how these two images come together. I can also drop ground control points, and that precisely pegs my mathematical model between these two images to the ground. Now here's the issue. Look at the steeple of that church, okay? And you'll see that now the computer understands the mathematical model, and it can see the difference in the location of the top of that steeple. That's your parallax, that's your relief displacement. And it now mathematically knows that the reason what's causing that is the actual height of that building. And so because it has that mathematical model, it can determine the elevation of the data. And so now the computer just runs very fastly and goes back and forth between the two stereo pairs, and it quickly finds the elevation points for all the matching pixels it can find on either image. And that's the importance of the stereo and the stereo overlap. We want to stress that as you go out and you start looking at your imagery and you want to ortho correct it, if you want to build 3D models, having that good stereo overlap is key. Now, the thing that we just showed you is more of a conventional, traditional photogrammetric triangulation model. But with the advent of drones, a new technology has started to come on board called structure from motion. And instead of having to have your images looking perfectly straight down as you need that in your conventional, more traditional photogrammetry, structure from motion lets you take imagery from all different look angles. And it takes advantage of the new processing power in computers to do that mathematical model. And our two software products, the ArcGIS Pro Ortho Mapping Workflow, works with that more conventional model where SiteScan for ArcGIS and our Drone to Map products uses that structure from motion. And these are the types of information products you can create, whether they be ortho base maps, detailed site models, the inspect and measure. These are the key derived products that you want to be able to generate from your photogrammetric process. And if I throw those two processing types down at the bottom there, you can see my conventional triangulation. It does really great on the ortho mosaics, the creation of DSMs and DTMs. But if you really want to get into that detailed site modeling, that inspect and measure, it really helps if you have a structure from motion solution that we make available in all our drone processing software. Another key advantage of the photogrammetry is that we can also work in stereo. And for people wanting to make very precise, detailed 3D models and extract features very precisely, you just can't beat stereo. So just being able to put on your stereo glasses and be able to look at that, you can do very precise 3D extraction. Unfortunately, we couldn't send you all 3D glasses today, but if you have some, you might want to grab them if you got them right by your computer. Kyle's going to be showing a little bit of stereo when we go through it, not a lot, but it's pretty impressive to see the details that you get from the stereo imagery as you go through the processing. And ArcGIS provides that ability to work with that stereo data. The other thing I want to point out is that when you go through the process, one of the things that we always generate are these detailed accuracy reports. And so this is the way that you can ensure that your data truly is authoritative, that it meets your accuracy standards, and that it can be used to share and extract your features and do the other information products that you want to generate from the source content. So this accuracy is very key. So this is just kind of the step-by-step flow of the ortho mapping workflow. Once again, the raw collection. We go in, we create a Mosaic data set of our different stereos, images that make up the block. We can drop ground control point to tighten those up. We do an adjustment to that data, and then we set up the processing to generate a digital surface model, which then in turn can be used to ortho correct the photos. So, but rather than talk about it, what I'm going to do is just have Kyle show this entire process to you. So Kyle, I'm going to make you the presenter.
All right, you see my screen, Kurt?
We can.
Great. Everyone, welcome to Malawi. We're going to zoom in now to the park boundary of Nkota Wildlife Reserve, which is in the central eastern part of the country. As we stated, there's a lot of really exciting things that the African Park Service has been able to do to reintroduce wildlife and help conservation efforts in this area. However, you can kind of tell in this map here, terrain is difficult here, and that is one of the challenges that the park faces. There are no, Calvin will be able to show you later in his demo, but there's not a lot of not a lot of roads, not a lot of development in this park, and so it can often take days for park rangers to traverse from one point to another. So what we're going to do is we're going to run analysis against elevation models to improve the conservation efforts in this area. Now, there's lots of elevation sources out there. Some of them are free. You know, Esri provides a world elevation service available for use in ArcGIS Pro, but this layer that you're looking at here is actually open data from USGS. Now, zoomed in here, you can kind of see the pixelation here. This is this elevation layer, which is free. It's at 30-meter resolution. Now, a lot can change between 30 meters. So this is great for certain things. This is great for basic corrections and some basic analysis, but we really want to be able to run more detailed analysis on this area. So instead, what we're going to do is we're going to use the ortho mapping tools available with Pro, and we're going to run them against some stereo pairs to generate our own digital terrain model. There are many different commercial satellite companies out there that will task satellites to collect stereo pairs for you. For our purpose, we just went to the Maxar catalog and we looked for historical stereo collected by them. And as you can see, when we zoom back into the park boundaries here on these stereo pairs, that they're covering about 75% of the park boundary, which for our purposes is pretty good. Now, I'm going to zoom into this part of the park. Again, the stereo is necessary because it provides precise overlap and angles that when overlaid together, they create a 3D view. And as you can see here, so it looks like there's just four images when we zoom back out. However, there's really 8 different images, and there's some slight overlap and shot at different angles that will generate a 3D view. So for those who do have stereo glasses handy, now is the time to pull them out. This is the view of these 2 overlaid stereo pairs in 3D in our stereo map. And you can see as I scroll around the different changes in elevation. We've got canyons and valleys down below, mountain peaks or hill peaks up here. And so from this, we can automatically generate a point cloud from these pairs, from which then we can use to generate a DEM. Now, the stereo map here, I'm not going to go too deep into this, but these stereo maps do contain access to all of our editing tools. So you can run more of a manual feature extraction if that's the workflow that you want to use. Again, what we're going to do is just go back and do this feature extraction automatically. So the first thing that I want to do is I want to put these stereo pairs into a Mosaic data set. One of the reasons I want to do that is because the stereo pairs come from 2 different sensors. 2 of the pairs are from WorldView 2, and 2 of them are from WorldView 3. And so what we can do is use this Mosaic data set to pinpoint to those different to those different stereo pairs. And then because all of the imagery in a Mosaic data set is all the pixels in it are called to on the fly, we can do some advanced processing very quickly on this imagery so that it displays properly. And so one of the things that we need to do is we need to calculate the statistics against the imagery so that it displays properly. And then the other thing that we'll need to do is we will need to add a geometric function. And so for this, we will want to use either the Esri world elevation layer or the USGS layer here. This will just help during the block adjustment portion of ortho mapping. And so once we have our Mosaic data set set up, we can come to our imagery tab, and as long as I have an advanced license of ArcGIS Pro, I have the ability to create a new ortho mapping workspace. And so this will give me a whole new tab to work in, so I can give it a name to the tab, add a description if I want. I can identify the type of imagery that I want to work with. There is a difference in how satellite, aerial, and drone imagery is calculated. I can simply identify a folder file if I want to by selecting the sensor type. So if I wanted to just work with WorldView 3 imagery, I could come to my folder, have it crawl this folder where my stereo pairs are located, and it will only grab the WorldView 3 images here. And then of course I need to grab a spatial reference. We're working in UTM zone 36 South in Africa. And then I can identify different data loading options here. You know, if I'm just working with imagery from a folder, I can identify my elevation source here for the correction. I can select the processing templates and as well change the different stretches, band combinations, etc. However, we made that Mosaic data set, so we're going to go back to the start, import and use an existing image collection. And this will just allow me to input that Mosaic data set that I created. And it'll allow me to identify whether or not this collection has already been adjusted or not, so I can skip certain steps if I need to. And then I hit finish, and what it does is it generates me a new area to work in. And this ortho mapping workspace gives me a tab that gives me specific tools. Now, the first tool that we would need to run is the block adjustment. Very simple. You can adjust the setting outputs for the adjustment and the tie point matching portion. You run that. This took a couple hours for us to run. One of the things that it did was it calculated different tie points. And so what these tie points are is common spectral similarities between the overlapping images that can then be used to adjust the imagery as necessary. And then from those tie points, solution points are generated as well. Pro will give you an adjustment report that allows you to see the level of overlap in the amount of solution points that were generated. And then once your block adjustment is run, go back to our overall extent here. You can manage your tie points. It gives you the tools for additional correction there and adjustment if you so choose. Or you can work with our product generators. We have an Ortho Mosaic wizard and a DEM wizard. So we're going to run, this is a 3D webinar, so we're running our DEM wizard, which takes you step by step, easy for allowing you to select your point cloud settings, select your matching method, and then identify the type of DEM that you want to generate, whether that's a terrain model or a surface model. We chose terrain model. We finished it. Again, this took a few hours for us to run. So instead, we're going to show you the final product that it created. And so when we zoom into this area, you'll be able to see that it creates a seamless DEM, digital terrain model of this area. And you can see here the resolution's a little bit better. I'm going to take us back to the map here, though. We're going to compare the USGS elevation layer with the one that we've created, and you can see it overlays very well. There's not a huge difference from here that we can see between the two layers. However, when we zoom in and we run the swipe tool against it, you can see how much better accuracy we're getting from that generated model using our tools. So with that, I'm going to turn it back over to Kurt.
That sounds great, Kyle. Thank you. And I want to recognize Maxar for providing that Worldview 2 and Worldview 3 imagery that we used for that. You can see that that satellite imagery is just amazing on the level of detail that you're able to extract from that particular data. So anyway, I'd like to just recognize them. Now, before I go into the next session, let's go ahead and open up another polling question. So the next poll is, what has been your favorite bright side to the COVID crisis? Has it been your stylish face masks, your hallway commute, your dog is extremely happy, every day is casual dress Friday, or no close encounters with the TSA? So what has been your favorite bright side? Go ahead and vote. And Raquel, let us know when you want to share it. Go ahead. There we go. Every day is casual dress Friday. So that's great. Well, all joking aside, let's go ahead and ask another polling question here. We'd just like to gauge your utilization of drones. So if you could go ahead and let us know the extent that your organization is using drones. So answer number 1, none at all. Number 2, we're investigating their use. Number 3, we have an initial startup program. Number 4, we're making extensive use of drones. So we'll give you a few more seconds. Raquel, as soon as it looks like most people have voted, go ahead and share the results. Very good. Well, it looks like we're pretty much even across the board. Initial startup program has just kind of started, so that's great. We appreciate that feedback for everyone. So I'm going to go ahead and share my screen, and so we can start jumping in and talk about drones and their use within ArcGIS. So about 4 or 5 years ago, Esri started working in drones, and we immediately realized that there's these different points on the planet where satellite imagery is just too big of an area and maybe is too expensive, whereas aerial photography is difficult to fly, hard to get, requires a contract with somebody to go out and fly. And so there was these missed areas out there that I call microgeographies that were a little bit difficult to go out and really collect good imagery of. Satellite was too much, aerial photography was too difficult. But drones have definitely filled this niche. And what we found them and what they're so able to do is that it's amazing how easy and simple they really are to be able to work with and process. Our training course for our flying drones and working with the data and processing is just a couple of days. You can be up and running. The quality is amazing, as we'll show you. It's extremely accurate, and the cost is just extremely low cost. Just about any organization could afford it if they want to get into drones. So we highly recommend using drones if you have those smaller areas that you want to map. Like we talked about under photogrammetry is the fact that you have 3 kind of categories of information products that you can produce. And drones are no exception. As we talked about before, they're even better than traditional photogrammetry for those detailed 3D elevations like point clouds generated from photogrammetry and different 3D mesh models in those unique inspection photos as well. And there's just some great examples of what drones can be used for. This is an airfield in Virginia. You know, it covers a little bit over 250 acres. And it was flown, and you can see the level of detail that we're able to get with this, and you're able to work with this data in 3D. So it's just this perfect 3D base mapping capability. Another application might be change detection. In this case, we've been working with FEMA and the Civil Air Patrol, and they've been collecting imagery over their different disaster areas. And we've been processing it in near real time for them and making it available. And you can see the level of detail that you get with doing that damage assessment and the change detection. And some organizations might want to use it to be able to track their progress on a construction site. Esri is actually doing this. This is one of our new buildings going on our Redlands campus. And once a week, we go out, fly it with the drones, and we start building a photogrammetric record of how that construction progress is going. You can see the level of detail in 3D. So our first drone product was actually a solution called Drone to Map. This was a standalone application that worked on the PC. It provided very high-end full photogrammetric processing and was seamlessly integrated with the ArcGIS platform, but it could stand alone. So you didn't have to have ArcGIS, which was somewhat unique from our product. So it was a true drone app. And it's a great product, and we still make it available. It's one of our best-selling imagery products that we have, and a lot of different organizations are using it. But we got feedback from our users, and you know, as they started getting more and more uses for their drones, you know, they just really didn't have the computer infrastructure to do all the different high-end processing that they wanted to do. And so they needed something a little bit more elastic that would scale. They also started collecting tons of different data. And so rather than store this all on local hard drives, they wanted to have a centralized storage location and an access place that anybody across the organization could get to it and start working with the data. And they wanted something that would work with the ArcGIS Enterprise. And so what we came up with is something called SiteScan for ArcGIS. And essentially what we've done is we have taken all the drone processing capability and made it into a software as a service solution. And so this is actually all totally runs in a web browser. You simply go out, fly your drone, you upload your imagery into the cloud, and off it goes. You set up all your parameters, your collection information, and then you're able to do, once you do the processing, you're able to do different types of exploitation and analysis of that data directly into the thin client and the tool that you're working with to process the data. So SiteScan for ArcGIS is a very powerful solution that we're making available to our users. And it's exciting on the type of information and data that you can do. The other thing that we've added to SiteScan is the ability to do flight planning. And this is an app that runs in conjunction with SiteScan that allows you to go in and set the different parameters to do your collection. As I talked about in my primer on photogrammetry, that stereo overlap is critical. And so what this tool includes is the ability to properly collect your drone imagery in such a way that it creates the information products that you want to generate. So if you're just interested in orthos, you just run the mowing the grass pattern that goes back and forth. If you want more 3D mapping, then you run a hatch pattern, and it goes forward and backwards and side to side, and it collects the imagery from all the different angles, so you get all the sides of the buildings that you need for your textures. But if inspection is what you want to do, then you can actually run an orbital pattern, and that spins around your target, collects imagery from a bunch of different angles, and lets you get that very high detail 3D site models, if you will. So, but rather than talk about it, once again, let's just show it. And Kyle's actually going to go through a demo of the SiteScan product. So Kyle, I'm going to turn it back over to you. There we go, Kyle.
All right. So this is site scan. And as you can see, we're working here in a browser. We're able to use site scan to easily upload imagery from drones and create 3D products. One of the really nice things about site scan is once the imagery is uploaded, it will just automatically run for you in the cloud. You can close your browser, it'll just send you an email when things are done. And so you know, we can add our photos here. You know, I've turned the photos on, and you can see that unlike the stereo pairs that we used previously, that we did use this orbital pattern so that we can collect information on this shed that we're looking at here. And so you can see when we pop open the image viewer, all of these images, instead of getting that precise overlap from stereo, it's just getting different angles of the shed so that it can use that structure from motion to generate the 3D products. Now you can see, just we'll turn on the Ortho Mosaic. This is one of the 2D products that it generates, but you can see just how much better quality the imagery is from the drone as opposed to our satellite imagery that we get from in our background base map here. So when we process all of these individual drone images in SiteScan, the first thing that it actually does before anything else is it will generate that point cloud. And so you can use this point cloud, you can extract it, and you can work with it here in SiteScan, and it can also be connected into Pro, across the platform, in the web, etc. But you can see just the high level of detail that we got of this shed, just in the point cloud itself, the coloring, etc. And you can see that even though some things weren't necessarily the target focus, that the point cloud also did a pretty good job of generating other nearby buildings, vehicles, and plant life. There are a lot of tools here directly in SiteScan that you can use for analysis. For example, we have a height tool. I can measure from bottom to top of the shed, get height, elevation. We can do that. We have an elevation profile tool as well. So I can come to the bottom of this hill here, grab a point, measure to the top of the hill, and it gives me that elevation profile. We also have a photo inspect tool that allows me to drop a point anywhere in the cloud, and then it will pinpoint me to all of the photos, all the individual drone photos in which that point resides, so that I can do manual inspection that way. So that's an introduction to the point cloud. Once the point cloud is generated, the next thing that you can do, or the next thing that SiteScan does, is it generates a mesh. It overlays that high quality drone imagery onto the point cloud and creates a seamless mesh for high visualization. So we can zoom in and we get an excellent 3D model of the shed. We can zoom in and you can even see like the level of detail. You can see the junk car here with its hood open. We can even see through the excavator here as well. And then the final thing that once it's done generating this, will actually, SiteScan will actually generate 2D elevation data as well. So it'll generate contour lines, generate a hillshade, and of course, it generates elevation models for us, both DEMs and DTMs. And so what we can do with these elevation models is, very similar to what Calvin will be showing with you in ArcGIS Pro. However, there are some tools here directly in SiteScan that you can use for quick analysis. So I can draw a polygon using my volume tool here, and we can get an accurate measurement of the volume of the shed based off of the digital surface model that was generated here. And so we get the net volume of the cut here that we can extract that number here. We can also look at the volume report in 3D as well and ensure that we're getting the right objects as part of our volume. And so how do we get these products into Pro or across to the rest of the platform? Well, you have the ability to export them locally. You can download them, both the DEM, DTMs, the contours, the point clouds, and the mesh, as well as the processing report. You can also connect directly to ArcGIS Online or ArcGIS Enterprise and share these products directly so that they can be accessed through the portal from Pro or across our suite of ArcGIS products. So with that, I'm going to turn it back over to Kurt.
Excellent, thank you, Kyle. And before we can move into our final section, let's go ahead and take one more polling question. So here's your polling question. To what extent does your organization use remote sensing and imagery? None at all. We only use imagery for map backdrops. We do visual analysis and comparison. We use it for all types of image processing analytics, or we have implemented artificial intelligence techniques. So just let us know the extent that your organization is working with remote sensing. And Raquel, as soon as you feel most people have voted, go ahead and share the results. Excellent. So I'm glad to see that very few of you are none at all, and that many of you are actually using it for more advanced image processing and analytics. That's excellent. Well, what we're going to do now is just talk very briefly about analytics, and then Calvin is going to show you how that works. So let me share my screen here real quick, and then we can talk about these capabilities. So hopefully you can see my screen. This is talking a little bit about the capabilities inside of ArcGIS Pro in the Image Analyst extension. One of the things that we try to do from an image processing standpoint is we're modernizing our approach to remote sensing. In the past, and this particular model still works, but in the past, it's traditionally been more the case where the expert, the remote sensing expert, knows where their imagery is. They go out, they find the image they want to work with, they do some type of analysis, they run some type of analytic with it, and then they produce the information product that the end user wants to use. We're trying to change that paradigm. What we want to do is we want to be able to take that expertise of that remote sensing person and actually embed their tradecraft, their knowledge inside of the workflow of that imagery, and then make that processing available as a service. So we only want to store that data one time. So Kyle just created elevation data for the entire Encoda Park. And so rather than create a number of different information products that have to be stored and managed and maintained, what we want to do is assign raster functions to that data that the users can call up on demand and on the fly. So simply they just go into their area of interest, draw their bounding box, and they just say, I want this particular product. I want a shaded relief. I want contours. I want some type of hydrological analysis. All this can be generated on the fly, and you only have to store the data one time. So that's kind of the more modern approach that we're trying to do. And so we've implemented this ability called Raster Functions, and we have over 100. I think that this slide is a little bit old. We now, I think, are up to around 154 different raster functions that we make available to our users. And these functions can actually be put together in a chained workflow, if you will. So you can do all this particular type of analysis. And essentially, you just store that workflow with the Mosaic data set. So when the user goes in and opens up, the consumer goes in and opens up that Mosaic data set, they just select what information product that they want to see, and the system automatically creates and generates it for them. We've added a number of great new capabilities into this solution to do these different types of advanced raster functions. And Calvin's going to talk about these and present these to you as well. So I'm going to go ahead and turn it over to Calvin now.
Hey, thank you, Kurt. Can you confirm that you could see my screen, please?
Yes, we can.
Okay, great. So in this demo, we will leverage the digital terrain model produced from ArcGIS Pro to improve the park's operation through various 2D and 3D analysis. So as Kurt mentioned, Nkota Wildlife Reserve is the oldest and largest reserve in all of Malawi. And in response to decades of poaching, African Parks is restoring the reserve through an effective counter-poaching program, community engagement, and economic development. And to this end, the park has checkpoints around the park's perimeter, indicated by the icons in red, as well as corridors and camps that rangers can use to quickly respond to crisis, which are indicated in icons in green. Now, to get a better sense of the park, let's start by visualizing the terrain. So as often is the case, the satellite coverage of our area of interest is incomplete. So rather than working with just what we have, we'll combine the output raster with USGS Global DEM to fill in the missing areas in these corners. Here are the two sets of DEMs from USGS at 30-meter resolution. I defined the clip extent to produce these smaller DEMs, which will be used in the raster function to combine and then produce the hillshade. You can access the raster function by going to the Images tab and clicking on Raster Functions. And ArcGIS Pro provides many different types of raster functions to process and analyze raster data. For our example, we're going to use the Mosaic rasters to combine the rasters from USGS and Maxar. Use clip to clip the output to the boundary of the park, and use a few surface model tools like void fill to fill the voids in the DEM, and hillshade to get the visualization we want. This workflow is captured and documented in the function editor, as you can see here. And what makes raster functions powerful, as Kurt said, is that all the processing is applied directly to the pixels in memory. In other words, when I run this function, it does not write any new raster file to the disk, which can be hundreds of megabytes or even gigabytes. So let's run this function and see the result that we get. Okay, let me adjust some of the layers. So here is the hillshade, and when I zoom in and pan around, the calculation is being performed on the fly. So because there's no intermediate data created, as you saw, the processing is really quickly, but most importantly, the analysis that we perform could be now iterative, which is important for exploratory analysis. So we'll rearrange the layer. I have the elevation layer already symbolized. I'm going to bring the below and also change this transparency to 30. Oh, let's try that again. Let's do it manually. Let's change it to 30 to get the visualization we want. And as you can see, Nkota has a very complex terrain with lower elevation to the east and mountainous slopes to the west, which makes the park challenging to manage. So now that we have a better understanding of the terrain, let's determine the best path to build a road between 2 points of interest. So part of Africa Park's strategy to better manage the reserve is to develop a sound infrastructure inside the park. To this end, the team is planning to build a new road that will connect from this source in the middle of the park to the north of the park in the destination. On the map in white is the existing network of roads inside the park. The background raster is the land cover, which consists of different types of forests, human clearing, agriculture, as well as where people live. So given the sensitive ecosystem and the difficult terrain as shown by this slope raster, building a road must consider all these variables. So by chaining the raster functions together, as you see here, I'm producing a cost raster to define which areas are better or worse to build roads. For example, if I take a look at the slope raster, I'm defining areas with gradual gradient, a lower cost to build roads, meaning more favorable, and areas with higher slopes, a higher cost to define areas that are more difficult to build roads. And I've applied the same concept to the land cover as well. The output of this analysis, of this function, is a cost raster, which we'll see just in a moment. And the red areas indicate areas that are unfavorable to building roads, and the blue areas around the coast, which are favorable to building roads. Now, to determine the least cost path, we need to run traditional geoprocessing tools, and it's actually a two-step process. First, we run the distance accumulation tool, which takes in the source where we're beginning our journey, our surface raster, as well as the cost raster from the raster function. The output of this tool are fed into this optimal path design tool, where we define the destination where we want to go. And as you can see from the tool, we're defining the best single path between the source and the destination. Once we run this tool, we get a result that shows the best path between the source as well as the destination. And we can see that the path takes us to the east, where the terrain is more forgiving. So this may look all well and good, but we know that there are multiple rivers that might make this proposed road not viable. So we have knowledge about two major streams, rivers that runs through the park, but we need to determine potential locations of other streams. And we'll do that in the next demo. So as Kurt mentioned, raster functions have set of tools dedicated for hydrology, which can be used to determine watershed and streams. These tools can be chained together to determine the stream network from DEM. So the fill, flow direction, and flow accumulation in this order calculates where the water should drain based on the slope of the terrain. An output of this is a raster that predicts potential stream locations, and we could run additional processing to extract the raster as a polyline so that we could run additional geoprocessing against them. So an output of this analysis shows areas of potential streams. And we see that the tool accurately predicts the two major river systems that run through the park, but also the smaller tributaries and river systems that feeds to the major rivers inside the park. So in the next step, we'll take these features of rivers to recalculate the optimal path. So again, we'll use the same process, distance accumulation and optimal path design. The only difference here is that we're using the stream as an input barrier raster. Now, what this means is that the tool will calculate the least cost path by treating the stream as a barrier that cannot be crossed. And when we run this tool again, we see that indeed the path goes around the river as opposed to going through the river in our original analysis. So no matter how good the infrastructure is, it is no use if the rangers cannot respond in a timely manner. So there are 5 ranger quarters and camps throughout the park. These locations serve as a base camp to launch operations. And in this analysis, we'll determine the coverage area for each camp, incorporating our understanding of the terrain, land cover, existing infrastructure, and the rivers. For this, we'll use a tool called distance allocation. The tool will calculate and assign an area to a source feature, which are our ranger camps. We also use the digital elevation model that we produced previously, as well as the cost raster. The output of this tool assigns an area for each respective camps. And you note that the boundaries actually follow the known stream locations, because we define the rivers as barriers that cannot be crossed. So this model can be further refined by tuning the cost raster and by introducing what we call source characteristics to generate a more realistic coverage. So let's move on to our final analysis. As mentioned earlier, there are over 200 camera traps throughout the park. These traps provide data on species location, population sizes, and how species are interacting with the human population. So it is important to install the traps in an area that will provide maximum visibility. For our final analysis, we'll use the DEM in a 3D environment to anticipate the viewshed of a camera location. So what's great about ArcGIS Pro is that it combines both 2D and 3D analysis. We can start from a 2D map that looks like this, but very quickly convert this to a local scene, which is our terminology for a 3D view. I've already done that, and we get a view like this. And this may look like a traditional 2D map, but when we navigate to an area of interest, we quickly see that this is indeed a 3D view. So while this terrain loads, I want to give you a comparison of the difference in detail between the USGS 30-meter resolution DEM versus the DEM, which is 2.5-meter resolution that we produce using Maxar's stereo imagery. And we'll let this load just a bit. Great. So we see that here, we see all the details in the valleys, the grooves, and even like the contours. So we're going to use this to understand the viewshed of potential camera locations. So let's do that right now. So you see the bounding box here, and the 3 points are potential camera locations. And we could use exploratory 3D analysis tools in Pro called viewshed to bring up the tool, configure the viewshed, and by using interactive orientation, we could interactively rotate to see which areas is visible and not visible. We could work with one or multiple, and even in one far here, select all of them and see dynamically which area is most suitable to install the camera location. So in about 10 minutes, we performed 5 types of analysis combining both 2D and 3D using DEM generated from Pro's photogrammetry tools. So while this analysis was based on a conservation scenario, the same methods can be applied to defense and intelligence. For example, supplying and reinforcing military troops in a deployment, or in a wildfire management, providing movement paths for firefighters between posts, and so much more. So I hope you found this demo helpful. And with that, I would like to pass it back to Kurt to finish up. Thank you.
Excellent. Thank you, Calvin. That was a great presentation. And I want to thank all of you for attending the webinar with us today. Unfortunately, we used up all the time, but we tried to answer the questions as much as we could in real time. We'll make sure that we consolidate those answers and get those out to you. One other thing, please, we've put together a survey. You'll be asked to respond to the survey. Please feel free to add your comments there. We would really appreciate the feedback there. The other things to remind you is that we have a couple more webinars going on. The first one is that we are actually having a imagery summit, which will be held on October 6th. This is a full-up session that will talk about all the details of the different imagery products that are available in the ArcGIS platform. So please look for that. Do a search on the Esri Imagery Summit and join us for that. It's a free event. And then the next national government webinar will be working with GeoAI, and that'll be held on October 14th. And then just kind of as a last note, if you want to get more information, probably one of the best sources that we have for imagery in ArcGIS is the ArcGIS imagery workflows. We have a number of workflows, some of the ones that we've shown you here today that are available. They're outlined in detail, and we provide videos that show you how to actually run those workflows inside of ArcGIS. So go ahead and take a look at those pages. And then also, if you get a chance, go ahead and take a look at africanparks.org. The work that they've done in Uncoda and the other nature reserves that they manage has just been tremendous. And we're just so impressed with the work that they've been able to do. And it's such a great resource for all of us that we should really treasure. So once again, thank you for joining us today, and we look forward to hearing from you in the future. Thank you.